see that types of memory. Okay, ROM, read-only memory. Read-only memory means that we can read the memory but we cannot write it onto that memory. Okay, that is called read-only memory. Okay, random access memory, you know that random access memory means the time to access any particular address, location, word of that word in that memory. If you want to access any particular address, location, data, the time required to read or write is same. I mean, same means it is same for all the words. Actually, it doesn't change, vary with depending on the address. Doesn't vary with depending on the address. It will be same for the all the address. That is called random access memory. Random access memory, the time required to read or write to all the addresses is same. Okay, that is random access memory. Okay, read-only memory. What is it? What is the purpose of read-only memory? Read-only memory is that it is read-only memory is fabricated with the chip. For example, you take BOIS. This is when the power BIOS program, when the power supply is on, there is a ROM, small ROM will be there, fabricated in the computer chip itself. Okay, fabricated in the motherboard. Okay, what will happen initially? It will run this program. Actually, this is permanently written and it is non-destructive also. It can only be read actually. So initially this program is loaded into the main memory and this program will run. What does this program will do? This program will check all the connection device, hardware connections and all the input output devices like that. It will check all those are connected perfectly. After that it will load the small portion of the operating system, so that from then onwards operating system will take the control of running the computer. Okay, this is ROM. ROM means read-only memory. This is permanently written program in the computer so that it will run every time when the system is on. This is ROM actually. So this is also called factory programmed ROM actually, because it is programmed in the factory itself. Okay, this is ROM actually, read-only memory. Okay, then random read-only memory, sometimes actually read-only memory not only for running BIOS program. For example, you want sin phi or cos phi, some data, mathematical data, value of some data. Actually this is also fabricated into ROM. Whenever the computer requires that particular sin phi value or some cos phi value, it will read that ROM actually, so that it will print. This is also factory programmed. Okay, so I mean this is already written. For example, sin 30 value, some value will be there. It is already written in the ROM. So whenever processor encounters some sin 30 value required, it will read this ROM actually, because already it is stored in the ROM actually. So ROM is non-destructive, because even if you read that, the data won't be lost. Even if the power supply is gone, it won't be lost. Okay, that you have to remember. That is ROM actually, read-only memory. Now random access memory can be classified. Random access can be classified as read-write memory. Read-write memory means you can write and you can read. That is, this is also called DRAM and SRAM. These are also used in the main memory. Okay, the processor directly interacts with this memory. Most of the times we'll represent memory, no? That is the main memory. Most of the times we'll show processor, memory. So there is a communication between this. Okay, this is main memory. Main memory is random access memory. Okay, random access means for whatever the address location, the time required to read or write will be the same. Okay, even if there are 1000 words, 1 lakh words like that. Okay, read write. DRAM and SRAM as the structural differences are there. In DRAM we are using capacitors, where in SRAM we are using flip-flops. Okay, we'll study more about DRAM and SRAM. Okay, the differences between them. DRAM, capacitors. Okay, roughly I can say the differences is that DRAM is cheaper, SRAM is costly, because it takes flip-flops. Flip-flops means it is used in the flip-flops. Here it is the only capacitor and transistor. So here there is circuitry is very less, so that lot bits can be put in the small area. Here it takes more area. But one difference is that there is a leakage here in the capacitor. Okay, data will be lost, so it can be continuously refreshed. Here there is not required to refresh continuously. One more difference is SRAM is fastest, DRAM is slow, and one more thing is that it is costly. This is cheaper. Okay, this density is high, this density is low, and that means area, bits per area. Bits per area is more here, bits per area is less here. So you see, even you know that Apple computes all the solid, most of the devices it won't use hard disk, it will use solid state devices. Okay, there are no rotating parts. Okay, next coming to the read-only memory. Read-only memory you don't interpret mistakenly, because it's also erasable. We can write it also actually in this thing. I'll tell you ROM, read-only memory. Okay, read-only memory means we already studied this BOIS, processor booting program, and some fixed location. Okay, that is ROM. PROM means that is programmable ROM. That means this is PROM means one time programmable ROM. Okay, that means the user will take the empty seed and he will write one time. That is programmable ROM. That once it is programmed, it can only read, but it can't be written again. That is programmable ROM. Programmable ROM means it can be programmed only once. It will fire, the circuits will be there, circuit connections will be there, like different types of models are there. I can say that, for example, gates will be there, and gates connections will be there, that connections will be fired actually. So depending on the value, it will be fired or open, fired or not fired actually, so that it will be stored 1 or 0. Those are programmable ROMs. These programmable ROMs are, once they are programmed, they can't be reprogrammed, okay, they can only read. Okay, next EEPROM. EEPROM means it is not, we can say the read-only EEPROM. EEPROM is even though we can say it as a read-only memory, EEPROMs are little bit slightly different, because EEPROMs is erasable ROMs, okay, erasable read-only ROMs. But here the difference is that we don't erase frequently, we erase them rarely, okay. So there are two types: electrically erasable program PROM and UV, ultraviolet rays, okay, UV light erasable programs. But electrical erasable lights are PROMs are more advantageous than UV PROMs, okay. So here the difference is that you have to remember that in this EEPROM or ultraviolet form, what will happen, that we can read it fast, read fast, but erasing and writing will take longer time, write slow. Okay, EEPROMs and UEPROMs, you have to remember this point. We can read the data from them is faster, but writing data it will take longer time. Okay, these are the types of memory. Learn about the flash memory. Flash memory is usually used in the, flash memory is nothing but whatever we use in the pen drives. Okay, flash memory is nothing but pen drives memory. Pen drives, we regularly use this thing. Okay, it is a form of electrically erasable PROM. Okay, a variety of electrical erasable PROM. The only difference is that it is not randomly accessible. Okay, randomly accessible means to access each and every bit, it takes the same. RAM means random access memory, means if you take same time to access each and every address of the memory, but it is not like a RAM. That's the only difference. In EEPROM, it can take the same time to access any address, okay, any house, for example houses, to reach any house it will take the same time, but in flash memory it is not like that. Okay, that's the only difference between EEPROM and flash memory. Okay, so it is not a RAM, not a random access memory. It will take different time to access different locations. Okay, it is widely popular because it's used in the fun times. There are two types of flash memories. One is NOR flash memory, made up of NOR gates, and NAND flash memory. Okay, NOR is the earlier invention, NAND is the latest invention, and it is most widely. We will first study the NOR flash memory. So in NOR flash memory, what we can do, that we can address individual words. Okay, we can address individual words. What does it mean? If the memory is there, if there are, for example, multiple bytes are there, 64 kilobytes, for example 64, so we can address individual, each and every location we can address. Okay, that means each and every word we can address like this, and we can erase individual words. The EEPROM, there is a difference between EEPROM and NOR. Here also we can erase individual words, but in EEPROM we can erase all the memory at the same time, because if you erase all the memory will go on away. But here we can erase individual words also. Okay, we can address individual words, we can erase individuals. Unlike EEPROM, if it is erased in EEPROM, it will, all the data will go away. Okay, that means all the bytes will go away if you erase in EEPROM. And one more thing is that reading is fast. Reading in from the non memory is very fast. It takes 10 nanoseconds usually. Okay, it is reading is very fast. Next, erase and write. For erasing and writing, it will take longer time. That means 100 times more time than the reading. That means for reading 10 nanoseconds. For erasing and writing, it takes 100 times, means 1000 nanoseconds. It is very slow. Okay, then we can erase and write 1 lakh times almost, without deteriorating the performance of the memory. 1 lakh times. Okay, 1 lakh times you can use it to write, erase and write. Okay, that is 1 lakh times. Next, spare blocks. So for example, if it is told, for example 16 GB pen drive, if it is told like that, okay, there is a 16 GB memory. In addition to that, some other spare blocks will also be there. 16 bit plus spare blocks. Even though he won't specify, there will be spare blocks. In addition to what is the purpose is that while manufacturing, some bytes are defective. Okay, that is one problem. And with the operation of the time, along the time, some will get deteriorated. Okay, that so there is a bad, that is called bad block, because the block which is deteriorated over the period of time, or it is if it is defective at the time of manufacturing, those are called bad block. So what is, there is a bad block mechanism in the pen drive. That means, what does it mean? If there is a block is defective, it will use the spare blocks. That block is the particular block which is bad, that is which is defective, it is blocked. That means it won't allow it to the write into that bad block. Okay, that is called bad block management. Okay, there is a bad block management is also there, and there are spare blocks also there to replace the bad blocks. Not replacing, bad blocks won't be used, spare blocks will be started using by the system. Okay, this is the way NOR flash memory actually. So it can address individual words, it can erase individual words, and reading is faster, writing is slower 100 times, and 1 lakh times it cannot deteriorate. 1 lakh times we can read and write. Okay, the performance won't deteriorate. It can also maintain spare blocks, and there is a bad blocks management system also there in NOR, but it is the oldest technology. Latestly there is a NAND flash memory is popular. Okay, we have learned about the NOR flash memory. Okay, now we are going to learn about the NAND flash memory. Okay, this is also flash memory and EEPROM. Okay, electrically erasable PROM, but it is like NOM, it is also not RAM. RAM means random access memory. You know that random access memory means, okay, the time required to read and write is same for all the locations. Okay, this is not a RAM. Okay, it will vary. Okay, so NAND in latest, all the latest pen drives will come in the NAND technology. Okay, this is latest. So what are the characteristics? Okay, like NOR, it is non-volatile. Non-volatile means it doesn't erase with the when the power supply is gone. So, okay, non-volatile, and read fast, write slow. You know that most of the EEPROMs are read fast. We can read it fast and write slow. Okay, then how it will organize the data? Okay, it will organize the data as set of pages. Okay, set of pages. Pages means one page means usually 512 to 1048 bytes of data. Okay, plus error detection bytes. Plus error detection means 12 to 16 bytes. That means one page contains 512 plus 12 to 16 bytes of error detection code. Okay, for the error detection. So this is called a page. Here one page means here it maintains data as set of pages. One page means typically 512 to 2048 bytes. Okay, plus error detecting bytes. Okay, so and also one more 10. In not only page, there is a term called block. One block contains set of 32 pages. Okay, you have to remember these two. One page means 512 bytes, one block means 32 pages. Okay, so pages can be readable and addressable. That means we can read a page individually. That means we can read 512 bytes at a time. Okay, and addressable, we can address the pages also. We can read the pages and addressable. But for writing and erasing, we can't do it as page wise. It will erase and write at the time as blocks. That means we can write 32 pages at a time. Okay, block means 32 pages, but we can read one page individually. Okay, for reading we can do it one page wise. For writing or erasing, it will erase 32 pages at a time. That's the only difference you have to understand. Okay, and we can do it for 10 lakhs times. 10 lakhs times. NOR is 1 lakh time. Here it is 1 lakh, 10 lakhs times. Okay, that means it can 10 lakhs times we can write without deteriorating the NAND flash memory. Okay, and the life, once we written it can hold the data for 10 years, almost 10 years it can hold the data. Okay, and there are error correction detection bits are there roughly. Okay, 12 to 16 bits. Okay, those can correct if you read some data, for example 250 bits. Okay, if there are 256 bytes, 256 bytes means out of 256 into 8 bits. Okay, so how much error it can detect using this error bits? So in 256 into 8 bits, if there is only one bit is wrong, then only it can detect the error. If there are more than one bit is wrong in this 256 by 8, it cannot detect. Okay, so probability is very less. 256 into 8 bytes. If there is only one bit is error, there are 256 into 8 bits. that is huge number. So in that, only if there is only 1 bit error it can detect, otherwise it can't detect. Okay, it can corner. Okay, so in the block 0 means it is divided into blocks. Okay, memory is done. In block 0 it will store the bad block table. Earlier also we discussed about the bad block table. Okay, bad block table means some are defective while manufacturing and some are will go defective by the usage. Okay, these are called bad blocks. For the counter the bad blocks, there are spare blocks will be provided, and bad blocks we stop using that. There is a bad block management system also there. So block 0 is always, block 0 contains bad block table. Okay, bad block table means which are the bad ones. Okay, which are not manufacturing defects are deteriorated with the time. Okay, the table will also vary because as the time progress more bad blocks will add, because more will deteriorate. Okay, the bad block table will also vary. So block 0 which is assigned to bad block table is always guaranteed to be readable. Okay, these are the characteristics of NAND memory. Oh, you see once it is non-volatile, means that when the power supply is gone it doesn't change the value. Okay, read fast, write slow. Okay, we can read it in terms of pages. One page means 512 to 1048 bytes, but we can write it as a block. That means we can read individual page, but we can write 32 pages or erase 32 pages at a time. Okay, 1 million times we can read and write. Okay, and life is 10 years roughly. That means it can retain the data for 10 years. Okay, error detection. Out of 250 bits, if there is only one bit is error, then only it can detect. If there are more than one bit is error, it can't detect it. Okay,